Nate is the executive director at Ohio State University of a program called Center for Design and Manufacturing Excellence, the CDME. How would you frame it as different than most technical education at the college level?
I think it's interesting that you started out that way. That's probably our biggest challenge is we look close enough to what other people have been doing for a while that we tend to get bracketed with other groups. Uh, I think we're pretty well. Starts to sound egotistical, but I feel like we're pretty unique.
That's
What
not
we
egotistical. How are you unique?
what we try to do is compete with the likes of Battelle, Southwest Research, EWI for funding. Edison Welding Institute is EWI, but compete with them for funding and use those commercialization and technology translation projects as a way to train undergraduate students while they're still in school. So we hire undergrads. This is their part-time job rather than working at McDonald's or the library or wherever might be. They elect to come here, and then we put them through a pretty intensive mentorship program that lasts 3 to 4 years, where they're doing the job that they will do when they graduate.
Yeah, there's a lot of technical stuff, and there's CNC machines and all sorts of, it's a research slash manufacturing lab, but the bidding process is there, and like the ability to learn how to integrate with existing teams at other companies. Like to me, that's a big part of what makes a difference too, which is not just the theory, but also the how that works day to day within a corporate structure.
Correct. Yeah, and we see folks in academia. We watch their brains melt when we tell them that we have undergraduate students write proposals. Like that's such a foreign concept, but it's what they're going to be expected to do when they graduate. So why wait until they graduate to put them in that environment?
Tell people a little bit about like just down to the brass tacks. Like what are the students like? What disciplines? What skills? Like what are they actually working on?
We create postings for students based on what we want them to do. Uh, we didn't used to do that. We used to create postings for like a mechanical engineering student or a communications student. And what we found was we would get students who were going after the degree, but they really didn't know what the degree meant. They just knew what they wanted to do. So over time, we started to react to the students we were hiring and say, okay, we want a student that wants to do mechanical design and programming, or they want to do AI machine learning with a bent on water conservation, or they want to do business management and finance, right? It doesn't matter what their degree is. You could be a mechanical engineering student or material science engineering student, but you want to go into entrepreneurship and business management. You would apply to a business position, not a material science position. And
Talk
so
about that a little bit more because I'm old and don't really have a sense of, what kids are walking in to college. Like, do you have a sense that a lot of the students that are walking into OSU that know they want to do mechanical engineering, for example, have any sense at all about where that role can exist out in the world? Like, or is it just really more at a top level where they're like, I understand I like machines and machining and all of this and I want to get involved? Like, where's some of that gulf occurring culturally?
yeah, I think they learn what degree they should pick in high school, largely from their counselors and what we see. And it's all based on Central Ohio and students coming to Ohio State. But what we see are students at the high school level. They go through a lot of career counseling. They take personality tests. They take career proposition tests. And from that, they're effectively told you would be a great fit for mechanical engineering, or you would be a great fit as a nurse or a doctor. Right. So they kind of they get directed towards degrees. Um, I think whether they know what that degree is going to do for them when they graduate or not, in their head, they know what they like. Right. Like we all, no matter what the piece of paper says, we know if we're attracted to machine learning or coding or we spent time out in the garage breaking hacksaw blades. Like we all know that. It's just that we don't know exactly how that translates back to the degree we're getting. So we stopped. We just said, okay, well, if you know what you want to do, Just apply for the job that does what you want, and we'll figure the degree thing out later.
Are you a manufacturer drowning in orders, juggling inventory and procurement data across multiple systems, or managing production manually? Then you may want to take a look at today's sponsor, DOS. DOS is an adaptive ERP that kills implementation hell by working directly with your team, connecting all your systems to minimize data entry so you can focus on production. Instead of barging in like a bull in a china shop, they take a deep look at your actual operations and they build a system that matches how you operate today, placing only the parts that need improving rather than trying to fix what's already working great. Does that sound like a team that you could actually enjoy working with? If so, head over to DOS.com, DOSS.com, use the link in the show notes, or tell them that Joel from Tool or Die sent you. DOS.com, one platform, total visibility. So give some examples of the kind of job postings that you're putting up over the last couple of years. Like what are some of the opportunities?
An easy one is additive, right? Additive is the nano of 20 years ago. Everything says additive. And students largely know that they want to go into additive, but they could be from any degree. They could be a mechanical engineer who also has a bent on finance and math, or they could be a finance major who is attracted to additive.
You would have a better sense of this than I would, but I will tell you, additive uh, gives me pause a little bit because I've had a lot of conversation over the last few months about how additive is less important right now for the demand side of actual businesses today than subtract CNC and subtractive building.
I think the answer changed about 5 years ago. So it was 100%. It was new and sexy, and everybody wanted to play in it. And it was the whole like startup community and VC funding was going crazy over additive. Uh, I think we're in our world, in our center, where we've seen it translate to is additives. Additives not the place you go to make 250,000 parts a month. Right? It just makes no sense financially. Uh, where it makes a ton of sense is if you are low low volume, high mix. So you're a stamping company or a casting company or like whatever X company, and you know that you need to make 10 of something. The tooling, using additive to produce the tooling makes tons of sense. It's the That's the place that we see a lot of organizations going. There are the aerospace thing, like GE has nozzles and flying parts and rotating parts, and Department of Defense is looking at flying parts and such. But most companies, the place to go for additive is tooling for high mix.
Tooling and prototyping. Yeah. Additive in this sense basically means like 3D printed something as a shorthand, but 3D printing for metal is probably or is a very different process than for plastic. And, whatever material you're doing is different. But a lot of those parts for hundreds of years had a certain process, and now digital makes it a little easier, and some mechanical processes to take something directly out of CAD where it's designed and just print it out of metal or some other stronger thing. As far as the industries go, do you work with like government and like dual use stuff, or is it more in energy? Like, what are just big categories that you guys tend to work with?
Yeah, defense and energy are the two largest industry segments. And then from a funding standpoint, it's pretty evenly split between federal funding and commercial funding in those two markets. So we'll work with Defense, Department of Defense, Air Force, Navy, Army, and then their supply base. On the energy side, similar model.
Where did you learn those skills as a young man trying to figure out like how to negotiate the world?
I think it started in school. I grew up on a small farm when I was a kid, but when I was in school, I had to pay for school. So I worked at a welder in a shop here in town. And that's how I put myself through school at Ohio State. I wish I would have had like money falling from trees or wherever it comes from, but yeah, I was working second shift. Sometimes I would pick up third shift and then go to school during the day. And parents helped. Parents were awesome, or still are awesome, but we didn't have tons of money. We were a little town in Appalachia and kind of did what we did. Uh, when I graduated, I went to work for a company called Swagelock. It's a tube fitting and valve company based out of Cleveland, Ohio. Uh, I worked there for about 5 years and was fortunate enough to get put on their oil and gas team, which was for somebody who's 22 years old, being in the oil and gas market for a company that's international was amazing. Right? Day one was go get a passport. Day two is figure out how you get visas to all these countries you never heard of before, and then travel around the world and try to figure out why fittings are or are not working in different environments and come up with solutions. And uh, through all that, I got really lucky and I was like, oh, what if we did this? Like one of those weird aha moments. And we were able to, myself and others at Swagelok, we were able to file a couple patents around these ideas. Uh, One of the faculty members here at OSU, he said he and I had a conversation at a conference or however we connected. And he said, hey, if you're interested, the patents you filed, those are kind of poised really well to do some graduate research around. We could get you a fellowship. So I came back to Ohio State for a fellowship. Um, Fellowships, for those that don't know, those are kind of code for we're not going to pay you very much money. We're going to work you real hard. So my wife and I at the time we loved the fact that we were able to come back to Columbus, go to school, um, but we needed more money, so we started a company. Which, in like retrospect, was the dumbest thing ever. If you need money, why would you start a company? Um, so we started a business with another grad student, and we were again lots of luck in all the right places. The business did well. We ended up creating a couple of our own products and had some of our own patents. Uh,
What did that business do?
We did chemical processing. So our main kind of technology was supercritical CO2. So like a weird little space that there's this fourth phase of matter that nobody ever really learns until they go to grad school. You got liquid, gas, um, liquid, gas, and solid, and then there's supercritical, which is like a fourth phase. It's a mixture of two of them. Um, so anyway, we you can use that supercritical phase as a solvent and very specifically dissolve out certain materials or certain elements at a time.
It's like a really fancy dry ice cleaning machine.
Yeah, right. Very much, yes.
That's cool. What kind of industries use that or need that? I would presume like aerospace or things that like you need to be able to clean stuff out but leave zero residue.
Right. Yeah, and there's a weird, kind of like a weird little space where because you can tune the solvency, uh, you can do things like decaffeinate coffee, where you only pull out the caffeine, but none of the flavonoids or the smell or the taste.
By like tuning the mix of it. What I'm sorry, we're gonna have to go down this rabbit hole a little bit because I this is new to me.
But there is a phase of matter that behaves like a liquid. So think of a liquid in a cup, and it behaves like a gas. So if you poured the liquid at the right temperature and pressure into a vessel, it will fill the entire cup no matter how much liquid you pour in. So if you poured a drop of liquid in, it would remain a liquid but fill the cup. If you poured a cup of liquid in, it would remain a liquid but fill the cup. It's a it's a very weird phase.
But it needs some pressure, I presume, to have that. Okay.
And it happens at very specific pressures and temperatures.
Okay.
Um, but it so the easiest way to think about it is maybe your like paint, right? If you had oil-based paint, if you went and bought paint thinner, you could clean your brush and it cleans the brush relatively well. Right? It might take, if you're scrubbing it around, maybe it takes you 30 seconds to clean the paintbrush off using paint thinner. If you have turpentine, it'll still clean the brush, but it's a really crappy solvent. So it might take you 2 minutes to get all the paint out of the brush. If you had acetone, you're going to burn all the nose hairs off, but it'll clean that paintbrush almost instantly. It's Those are different solvencies of hydrocarbons. So acetone, paint thinner, and turpentine are just different. There's like a solvency coefficient. Um, you can you can tune them. So you could pick a solvent that only removed one type of oil-based paint, and every other type of oil-based paint would be left behind. You can do the same thing with supercritical CO2. You can operate at a temperature and a pressure where the only thing it wants to dissolve is caffeine.
Yeah, awesome. So you guys set that company up, and you've sold that company you're not part of now,
I'm
like
not part
this
of
is
that
your
company
full-time thing.
anymore. Right. Yeah. So it's my business partner. I went to work for EWI, Edison Welding Institute. Um, I was there for about 10 years and left EWI to be part of another startup doing oil and gas work. So we were building pipelines and gas plants. Uh, yeah, it seemed like it was a great opportunity. I think it was a great opportunity right when oil and gas was really picking up in Ohio. And it lasted as long as the oil and gas boom in Ohio lasted. And then in 2013, 14, oil and gas market tanked. The business was, we were still pretty young. We were only 2 years old at the time. So we kind of fizzled at the same time.
What's Ohio's oil is mostly nat gas in
It
Ohio?
was, at the time, it was shale.
It was shale?
So that
Okay.
was right when the shale boom was really going crazy. Uh, yeah. So we had some cool marquee projects. We built the biggest, at the time, the biggest and longest pipeline in Ohio. That was our company. Yeah, it was a great experience. I definitely wouldn't trade it. Just the market crashed.
Yeah.
So um, it was about, that was like I said, 2013, 2014. OSU was looking to start CDME, and I had heard through a friend or faculty member, hey, this might be something you're interested in. So I threw my name in. The dean for the College of Engineering, he said, let's do this. And at the time, we had this plan that made all the sense in the world, that we were gonna create a space where um, faculty and graduate students could take their ideas. So they have all these brilliant ideas every day on campus, and they normally don't have a place to take them. Right, like it takes money and expertise to to pull the, like, the napkin sketch of the flux capacitor and build a flux capacitor. Right? Those sketching it and building it aren't the same thing. So we were going to be that place, and we had, yeah, all these crazy dreams that if we did that, OSU would become the entrepreneurial mecca. We would, yeah, people would flock, faculty, students, industry. They would all flock here because we were just kicking out so many technologies. It it turns out that the reason that universities and professors and faculty and researchers don't do that is because they like being professors and researchers. They didn't aspire to go eat ramen noodles out of their garage while they launched a business. So the idea was a cool idea, and it allowed us to, like, build this space that had equipment, and we had a few engineers at the time, and we had kind of like this underpinning of a place you could make cool things. But the business model wasn't working out. We were financially really unstable. So then we did what we should have done from day one. And we just, those the engineers and staff that we had, we all, like, flicked out our Rolodex and started just, like, flicking business cards until we found some people that still were working in leadership positions. And we said, when you call OSU, or you've got that, like, 1-800 OSU phone number somewhere, when you call it, why do you call? And they're like, dude, I know you're not dumb. You have like 66,000 students. Like, that's why we call. There's a lot of other things that we do at the university, but the students are the reason we call. So that's when we rebuilt the center. That was like what were we thinking? Hey, why would we do anything without fully engaging the students? No matter what business model we were going to go forward with, we 100% knew that it had to be centered around the students. Uh, so we did kind of evolve a couple times. It's very much like those rides at Cedar Point or Kings Island where you're like driving the car, but you're not actually driving it as.
Yeah. Well, and it makes sense too, right? Like the model for so long, especially coming out of tech, was like you go to school until you have your big idea, then you drop out and you become an entrepreneur. How many people are running through? How many students are running through the program any given year?
So in a given year, we have about 150. So this prior academic year, we had 153 students. Uh, the number of students we have is dictated by the number of staff we have. So we're now going on 11 years of running this model. And what we've learned is if you deviate too far from 5 students per mentor, things go off the rails. And so if you have too many students, you really can't mentor them. This is very like fictitious, but you end up with like the students sitting in the corner playing on their phone, or the students that don't come in and just punch their time code. They're not really getting the value out of the center like we want. If you have too few of students, then you use this tacit knowledge transfer, which interestingly is what academia is really good at. Like they faculty and professors and research scientists and academic institutions around the world, they've realized that they as an individual, they can't transfer the knowledge from one student to the next over generations. But if you have a big enough team, the students will transfer knowledge on their own. Right? You're always like, no, this is how you use Excel. This is how you run that machine. This is how you right? Every single step for a new employee, it becomes incumbent on the staff member versus a team of five. Like a new student comes in, the other four will like, come on, we're not going to let you get hurt. Let's show you how to do.
I love that your distillation of the program is we're going to show you how to run Excel and we're going to show you how to run a machine. Like that kind of is the core.
I think our freshmen and incoming students are probably frustrated because when they come in, the first things that we do are we try to teach them how to be professional staff. And that's something that, especially as freshmen or early sophomores, they've never seen before, right? They still think it's okay to show up in flip flops. They don't understand why they have to wear pants to work, right, instead of shorts. Um, they don't they don't recognize the value of words, which is like something that it's really hard for me to wrap my head around because we see it every day when you use the Excel example. When an incoming student, you say, "Hey, I need you to work on this. Just put it all in Excel, and then we'll figure out what the next step is." And you like, give them a mass of data. They come back to you with a Google sheet. They're like, like, Google Sheets not Excel. They're like, no, I think it is, right? Like, no, it's not. And they like in there for whatever reason, they've not been taught that through high school and wherever else they were at. They've not been taught that words are important. And when somebody says Excel, it's not Google Sheets or a pad of paper with lines on it.
I was like a summer farm kid. Like I grew up on farms all the time, but I didn't like, live on the farm. But that's where I learned that kind of stuff is if I'm out with one of my uncles or whatever, and they go grab me this tool from this place, and it looks like this. Like they gave me all the pieces there, but there's like a processing step in a lot of people's lives because I think there's a lot of non-technical interaction that people go through where they don't understand that that's a time where there's it's almost just like machine language. It's just like I'm telling you specifically what it is. Yeah, I don't know why that is, but my suspicion is always just we don't give people and definitely kids enough opportunities to be in those sort of interaction spaces. Like that's like an initial challenge is just getting kids to understand like this isn't about dressing you down. It's literally just about a method of interaction that you have to learn. It's non-negotiable.
Right. Like one of the yeah, it's funny you said the way you phrased it. Um, like everybody who's done anything in the military, you learn discipline, instant will and obedience to orders, right? Somebody says go do this. They don't mean go do something that's kind of similar to this. Right? You just do it.
Yeah. So a lot of the first year stuff is just learning hierarchy, structure, protocols, some basic civility. Then where do they move forward into?
Being professional in everything. Right. So like how you dress. Right? You dress the job you want, not the job you have. Email. Why is it important to have an email signature? Like all the little things that we learn over time. Make sure your phone number is on the email because if John needs to get a hold of you or Sally wants to contact you, you don't have your phone number on there, they're not going to be able to do it. At the first year in the center, it's getting through all the stuff that you learn in that first year of your career after you graduate. We're just trying to do it early. How do you, we get, we get vendors that send parts to us all the time that are incorrect. It's very easy for me to call and be like, hey, dude, I'm the executive director for CDME. You sent us the wrong stuff. And they would, oh, we're sorry. They'll like make up their thing and they'll fix it. It's it's levels of order or orders of magnitude more difficult for an undergrad with effectively no experience to call that same vendor and be like, and they have to, I hear the words they say, but they have to figure out how they're going to tell a vendor that they sent the wrong parts. Okay, and it's just like they got to get build the confidence up. So we let them and encourage them to do all of that.
I was just talking to uh, uh, Jim Bolosic, who runs Send Cut Send, and talking about even internal to their shop, trying to get every single person to touch every single machine, even if that's not ever going to be their job, just because it gives them a better understanding of like making high level choices, is saying we can expect this much throughput, or this is what safety looks like, or this is even just pure capabilities, like what it is. So you're letting people, as far as like the machine experience and knowledge, is that where it starts to get a little more like project based, where it's like, okay, they've kind of got a bid that they're addressing, and then you guys go, well, this one might need a brake press, so like we're going to teach you how to do some of that work. Like
It is.
where's that stair step up?
Yeah, and it starts, so it is project based. So because we're funded by the projects we go after or that we win, we can't we can't or we don't have the latitude to train every student on every piece of equipment just because it feels good. Right. So when a project comes in, let's say requires a wire EDM, if it requires that piece of equipment, there's already going to be a student who is trained on it and they're going to be running the equipment for the project. There's another student who's further in their time in the center who is capable of training other students. So it's a little bit of like learn it, do it, teach it. So the student that's running it is the one who's going to deliver the executable parts for the project. The student who's never seen or had to write EDM on a piece of paper before, they're going to be trained while the project is taking place. And the student who's done it for a while, they're going to be the trainer. So
That's
they're going
cool.
to be the one that's like, hey, this is what's happening right now. This is why student X is making these changes, or this is why she's adjusting this at the time. So they can one can be focused on the project while one is learning and one is teaching.
Is that kind of what the senior, like once you go through 4 years of CDME, like is that where you're really landing in that last year, is more of like a teaching and aid, or is there a final project? Like what's kind of the big finish?
Yeah, there's a good job. We use a teaching tool that's put out by NIMS, which is NIMS is the National Institute of Metalworking Society. They run it's like an experience based tool for tracking the training of individuals. It was originally built for like apprenticeships. We've we worked with them to modify it for undergraduate students. And it has that whole thing of you have to work on equipment for so many hours, you have to read so much about the safety and protocols. You have to know what the 5S requirements are, like how do you clean it and keep it sustainable and maintain it and everything. Because we respond to the needs of our customers, the equipment we have, it doesn't get stale. As soon as equipment gets dusty, we have to get rid of it. We don't have a whole lot of space, so we're very focused on whatever industry is paying us to do. That's the equipment we have to have. So when our customers come in, I'll give an example. We had one a couple of years ago that saw we had an industry scale die casting machine. And totally, we're the only university in North America that even has die casting. Period. But then on top of that, we have a die casting cell that you would see at like a Honda facility or a um, yeah, any automotive or aerospace organization. One of our customers came in that had been on a tour, and they were like, "Holy cow! You have an LK diecaster." I was like, "We just bought 7 of those. I will hire every one of your students because nobody's ever seen one before." Like industry's trying to implement die casting and vacuum die casting all across the country for automotive and aerospace. Students coming out with a undergrad, master's, or PhD, they've never seen one. Our students are running them every day. So it's just the tools that they're being exposed to, just being exposed to those tools are giving them job opportunities that other students won't have an opportunity to.
Do you think if you 10x'd the program, ignoring what that would be, in the what it would take to 10x it, but like from a demand side, do you figure if you could run even more programs like this or at larger scale, that do you have any sense of where that would max out, or is it just so sky high that you're like, we know from the company side they would take everybody we could train?
I think they would take everybody that we could train. And I think the place that the US is like my soapbox, the place the US needs to go is it'd be great if we get more support. But what we're trying to do here, it should be replicated regionally across the country. Like we see very specific regions that work with us, and they tend to be those that have always supported Ohio State. So you can think outwardly like a 90-minute drive from central Ohio. That's our largest customer base. There are flyers, Air Force, Navy, right there. They're kind of scattered across the country, but they care a lot about what we do in general. I think you could, if you took our model and you copied it or franchised it 20 times or 50 times across the country, it wouldn't affect our business at all. It would, if anything, it would increase our business. Because right now we struggle the most with getting people to understand who we are. I feel like we have this weird environment where we're taking undergraduate students, telling them we're going to give them zero credit towards their graduation, but we want them to work 20 hours a week. And when they're done, the only thing they're going to have is more bullet points on their resume. An industry comes in and says, "Yeah, well, can you like, do you have a booth at your career fair?" I'm like, we don't have a career fair. Yeah, we take an absurd amount of time explaining to parents and to students what we do, and to industry coming into the university what we do. We have about 37 staff, and the staff are a mix of um, technical experts that came from industry, like myself, and administrative support. Um, those 37 staff mentor or advise the 150 or so students. So that's like the matrix or the mix. What's hard is to make this work, we have to generate through proposals every dollar that it takes to turn the lights on and pay salaries and buy notepads and pens and
It's a
like
business.
that's right, it's a business. And in a university environment, you're for good reasons, because we're supported by taxpayer dollars, even though we're a standalone business at the university level, we can't make profit. Right. So tons of great reasons for that. I don't dispute it. It just makes it really hard. So if think about your business, anybody's business, when business is good and you're making margin, people question like, why are you making money? You need a new boat. Like, what's going on? Why do you have such a nice car? And then as soon as business slumps, nobody understands like, how did you continue to pay salaries, or why did you lay people off? Right? If you don't have margin in the good years, you can't keep the staff alive in the bad years. And when you're in an environment where the the message and the protocol is you break even and that's it, it's really hard. Right? You we're always in a situation where we're trying to outsell our capacity, but only win what we can execute, which is it's a tough balancing act. Biggest difference between what we're trying to do and that in the typical environment is that we don't teach classes. So in in most other places in academia, the research supports a lot of stuff, but it is cyclical everywhere in the country on the research side. But tuition is relatively constant. So you have this constant bed of tuition coming into universities that you basically you could build your business off tuition, and then the research, it can be variable because of that constant of tuition.
But yeah, just trying to understand how this could be replicable, because I would love for some other people to pick up the phone and call you and be like, Nate, I love what this is, what you're doing at Ohio State. Like, how do I structure this?
Yeah, and we've made it, or I guess I've made it harder because of experience. So examples like you gave, and in my prior life before I came here at EWY, that was a spin out Edison Welding Institute was a spin out of OSU. So it started out with similar foundation. We're gonna have it was graduate student based, but have graduate students working on welding research, supported and mentored by faculty and staff. And then when it spun out, it that mission stayed pretty constant, but the bigger it got, the more important the revenue became. The more important the revenue becomes, the less important the student engagement becomes. And then it's a, I don't know what their numbers are now, let's say a 150 person, I guess 30 million a year organization that has probably the same number of students engaged that it had when there were 20 people working there. Right. It's just when you go that 501c3, the research nonprofit route, you can spin out, hiring's more flexible, the
Mhm.
business becomes more sustainable, but your attention to what matters changes. Right.
And
So
how are you guys structured from a corporate standpoint?
so
Like,
we are Ohio State University. We're inside the university. Well, we sit inside the College of Engineering inside of OSU. But we're not a 501c3. Like all of our paychecks, students and staff, they all say
if I were working at an engineering school somewhere else in the country today, and I was looking at piloting a program like CDME. Uh, first of all, I presume I'm just going to tell they can call Nate Ames. His phone number is on the website. You can track him down tomorrow. But if you were telling somebody like, "Hey, this is a really successful program that I would love to see 20 more of across the country," what would be the kind of framework that you would say like, all right, these two or three things need to be true if you want to pursue standing something like this up?
it's got to be run and staffed by staff, and that's a difficult thing to come to terms with in a university setting. So um, I love our faculty. We work closely with them. They're what keep the engine of the university going. That's what it takes to run this center. Is you have to be willing to go to where the customer is, to go meet with them, go sit in their office. We actually have a desk in some of our customers' facilities, and some of our customers have desks in CDME. Like that's the environment it takes to run this. And if we're true to what a faculty member or a professor is doing and who they're teaching, they can't leave. Right? Like I don't want them to leave every week or multiple times a month. They need to be present to run the center, to run the
That needs to
activity.
be their first priority.
That's right, right. Um, yeah, and then things like sabbatical would fall apart if I just kind of take off for 6 months or whatnot. You need to stay here, right? The other the other is that I think undergrads are important, and academia in my lifetime, I suppose, has really leaned into grad students. And not in terms of the numbers, right? OSU has 66 or 67,000 students, 52,000 of them are undergrads. So we clearly have a lot of undergraduates and undergraduate focus. But when it comes to mentorship and experience based learning, most of that happens at the grad level, not the undergrad. Um, I think I think the reason the numbers are 52 to 67,000 is because industry's hiring that ratio, right? If industry was only hiring master's students or PhD students, everybody would go to grad school. But people are getting jobs with an undergrad. We should um, we should continue to lean into what industry wants to hire. Most undergraduate students at universities across the country, they end up with if they do two internship rotations, so they go like the last 2 summers of their career, they end up with about somewhere between 700 and 1,000 hours, depending on what their semester or quarter schedule looks like, of work experience, like true in the job, doing what they're going to do, work experience. Uh, there are some organizations or universities like University of Cincinnati is the closest one to us that has a very regimented rotation program where students graduate with an undergraduate degree and 3-ish thousand hours of experience. If you if you take if you take that and you say, we still want them to go do internships. So I still want my students to leave 1 or 2 summers or semesters throughout their academic career. And I want them to work 20 hours a week and work full time here in the summers that they're not going to an internship. They end up with about 5,000 hours of experience. So going back to some all kind of tie all the conversations we've had together, but all of it really comes down to experience. Right? Like what makes somebody more valuable 2.5 years after they started their career than the day they started their career? It's experience. Right. So if we can give them that same experience before they graduate, then the companies that hire them start off in a better. Students need their time to learn how to be professionals. And the shorter we make that time, whether it's in academia or elsewhere, all we're doing is pushing the cost and the national competitiveness. I don't know if there's a better word for it, but the cost and the competitiveness, we're just pushing it to somebody else, right? You don't, you just can't learn to be a professional until you do the work. And all like taking it away from the students while they have the opportunity to do it in university. We're just saying, okay, you, Boeing, GE, Lockheed, whoever you are, our expectation is you're not going to do that.
The real world job experience. And, when you talk about like who makes the best coffee, like that stuff is so hard to teach kids who have never worked in these different environments. And I guess the distinction I'm trying to make is like, I worked as a uh, journalist for a long time and kind of learned that industry and how different newsrooms and different publications worked. But then in the last 10 years was a consultant and probably have walked in and collaborated with, I mean, dozens, if not hundreds of different companies, and they all have different tones, and some have different norms and practices and even language and all of that stuff. And what I learned through that experience was like I walked into some places and I went, "Oh, I thought they were going to be like this sort of environment and the people would act this way and the work got done in this way." But it turns out I was totally wrong. And sometimes I was right. But, it's like when you go through that process enough and you come out of the other side and you say, the next time I have to go solve a problem or I take a job, I now know like these are the places where I thrive. And these are the things about myself that I need to change, that it turns out I thought were important and weren't that important. And what I think is really cool about the hands on experience, whether it's through CDME or an internship or whatever, getting a taste of that early while you're still finishing your degree and really still making career plans, I think is invaluable because you may have decided you wanted to do mechanical engineering because you really think robots are cool, and then you get into an environment and you realize the places where I can get a job for this are not the industries I want to work in. I don't like it, the corporate culture or whatever. So much more valuable to have that realization and real world experience like in your sophomore year than it is, after you after you graduate. And I think you see that anecdotally anyway from tons of people who leave university with a degree and then they spend 2 or 3 years in the industry they thought they were going to be in, and then they become, like a beet farmer. Like they're just like, turns out like I just wasn't cut out for that. And yeah, I don't think there's ever going to be a perfect solution, but I want to underline that I see and I respect that even though you have a hybrid business and academic model, your lived experience is like, let's not rush kids and students through their entire education very quickly. Let's try to dovetail in different parts of the real world with also this kind of protected learning environment where they can make their own decisions. Uh, to me, that's a much more respectful view of young people and like their own humanity is be like ultimately you have to take responsibility for this for a lot of your own choices, but we're going to expose you to a lot so you can start to make educated choices about that. I think is a great model.
Like those decisions, like to be a beet farmer, decide it while you have a chance to make a change rather than 4 years into your professional career where it's like, oh crap, now I'm not going to afford the house I bought, or like decide today.
Yeah.
And it does happen in the center. And when it does, it's, oh my God, go home. That's when you go home. I tell my wife, like, so amazing. This is why we do this.
If other people in universities are interested in this model, and of course companies that might want to work with CDME specifically, uh, they just show up at your house, knock on your door. What's the best way to reach out to you?
Yeah, the easiest because other people monitor it is um, CDME at OSU.edu. My email, my phone number, like you said, they're all over the website. Somebody can get a hold of me if they want to. Um, yeah, I do take Navy assignments, so I vanish every once in a while for short periods of time, but somebody's always monitoring the main CDME email address.
And if there are there any industries or type of businesses that you would love to get working with CDME that don't currently? Like who would be like a dream partner that could reach out and kick off a program?
We're touching a lot of industries. I think the one that we haven't found a way to engage with yet is semiconductor, which is interesting. It's something we talk about in the center's leadership meetings because semiconductor is growing very rapidly in the state of Ohio, and but they're not engaged with us. So like the Intels and the Cellflex and stuff, the companies that are really like, making chips and doing things like that, they're not working with us. And I don't know if it's our model doesn't connect well or we haven't found the right people. Uh, Beyond semiconductor, we're pretty well integrated. Oil and gas, automotive, aerospace, biomed, uh, cybersecurity is kind of prolific across everything right now.
All
But
right.
it,
So if you are a semi company developing FPGA early prototypes for beet farming
there you
enhancement,
go.
reach out to Nate Ames at CDME. Thank you for coming by, especially so early this morning. And we'll check in a while. I want to dig deeper into a lot of the specifics. And next time I'm running through Ohio, which will not be too long, I'll knock on your door.
Yeah, please do. Yeah, it was great. I appreciate the conversation. Anytime we can talk about the center, I'm always available.
Sounds good. All right. Have a good one.